In January 2026, astronomers confirmed something that broke a record scientists thought was safe for at least another year. A single galaxy, spotted by the James Webb Space Telescope, sat so far away that its light had been traveling for over 13.4 billion years, meaning we're seeing it as it existed when the universe was barely 300 million years old. That's not the surprising part. The surprising part is that it shouldn't have had time to form at all. Under the standard model of cosmology, the one that has explained almost everything we know about how the universe grew up, galaxies are supposed to be late bloomers, small clumps of gas collapse first. Those clumps merge slowly, patiently, over hundreds of millions of years, gradually assembling into the great spiral and elliptical galaxies we see today. It's an orderly process. It takes time. But Webb keeps finding galaxies that didn't wait. Surveys like SEERS and JWST turned up dozens of candidates, bright, structured, sometimes surprisingly massive, sitting at distances astronomers weren't sure the telescope would even reach. Some early estimates suggested a handful of these galaxies had already built up as much stellar mass as much larger, older galaxies nearby in the universe. If those numbers held up, the timeline for how fast a galaxy can form stars would be broken. It gets stranger. Some of the most puzzling objects Webb found weren't just early and massive. They were already finished. Astronomers identified a galaxy that had essentially stopped forming new stars only about 700 million years after the Big Bang. Old and quiet, while the universe itself was still less than 5% of its current age. Something out there had already lived fast, burned through its fuel, and gone quiet on a timescale that barely left room for a beginning, let alone an end. Follow-up spectroscopy has been sorting the real giants from the illusions. Some of that early brightness turned out to come from something else entirely. And that something else turned out to be an even stranger mystery. Scattered through Webb's deepest images, astronomers began noticing small, compact, unusually red dots. Not quite galaxies, not quite stars. They nicknamed them little red dots, and for a while, nobody agreed on what they actually were. Here's where the story gets stranger. Their light wasn't spread out like a galaxy full of stars. It behaved like it was coming from one incredibly small, incredibly energetic source. The leading explanation, reinforced by a wave of research through 2025 and 2026, is supermassive black holes, feeding on surrounding gas, wrapped in thick cocoons of dust that redden their glow. Some researchers have started calling them black hole stars because from the outside, that's almost what they look like. That single idea creates a much bigger problem. In the nearby universe, there's a tight, well-tested relationship between a galaxy and the black hole living at its center. The black hole is normally a small fraction of the galaxy's total mass. It's one of the more reliable rules in astrophysics. The little red dots don't follow it. In some of these objects, the black hole appears to weigh nearly as much as the entire galaxy around it, over massive by a factor of 10 in some analyses closer to 100, compared to what nearby galaxies would predict, which raises an uncomfortable question. How do you grow a black hole that enormous, that early, without breaking physics? Normal black hole growth has a speed limit called the Eddington limit, a natural cap on how fast a black hole can feed before its own radiation pushes the surrounding gas away. Start from a black hole formed the way a single collapsed star would leave one, and even growing at the maximum allowed rate, there simply isn't enough time in a few 100 million years to reach these masses. So, either these black holes started unusually large, collapsing directly from massive clouds of primordial gas, and skipping the star stage entirely, or they found a way to feed faster than the Eddington limit is supposed to allow. Both ideas are currently active, competing hypotheses. Neither has been confirmed. Both would rewrite part of the story of how the first galaxies and the monsters inside them came to be. Webb hasn't settled which explanation is correct, and more spectroscopy is underway to narrow it down. But the pattern itself is already hard to ignore. Twice now, the same telescope, looking at the same early universe, has found structures that grew up faster than the laws of physics were supposed to allow. Maybe the first billion years of the universe weren't quiet and patient at all. Maybe they were violent, efficient, and strange in ways our models never anticipated. Some researchers are asking whether this is just a gap in the models or a sign the standard cosmological picture itself needs revising, and if the universe was already building things this extreme before it had time to. The real question isn't what Webb found. It's what else is still out there, waiting to break the next rule we thought we understood.